Okay, so we are going to start now that Albert is here. Oops. So the first talk is by Mykle Hansen, which is an independent artist from the US, but moving to Germany, to Berlin. And so the title is Weather Organ, a Sparse Stochastic Synthesizer in Faust. And Mykle has a lot to say about using noises and randomness in general. So thank you.
Thank you. How's the microphone? Is anybody hearing me? Are they hearing me online? Is it working okay? Okay, cool. Hi. I'm gonna try and speed this up as much as I can so we can all get to lunch on time. This might be the least technical presentation at the conference this year. I'm really attracted to the simplicity of some of what's going on in this system. I'm describing basically a Faust application that I wrote that's using sparse noise, random numbers, and probability to create a variety of interesting sounds that to me match up really well with a lot of naturally occurring sounds, rain in particular, wind as well. And it's interesting because I've been in Faust playing with it and learning it and getting really excited about it through most of 2017. I've been talking to other people in Portland about it. I taught a class at Dorkbot Portland about it. And I've been wanting to do something significant with it, but had not really been intending to make this thing at all. And when I say this thing, I believe right now, listening to this one, this is Weather Organ's basic interface. A lot of knobs. What was going on, and I should mention that, of course, there's a paper that has been submitted and accepted. It's got a lot of details of the technical layout. All of the interesting pieces of code are talked about there. There's also a GitHub repo listed in there. So I encourage you all to have a look at the code. But I don't think that there's anything that groundbreaking or sophisticated in the code. It was just sort of interesting to do some necessary algorithms in Faust. And I'll talk about the ones that are interesting to me. I got started really weirdly in this. Sort of a confluence of three different things happened to me all at the same time, January of this year. One is a kind of a funny story. My family wanted to watch this really great movie called The Sound of Noise, and we went on Amazon and found it. But then we also found that we had the other option of listening to 8 hours of a box fan, or some jungle waterfalls, or some heavy rain, some nature sounds, some lightning sounds. If you dig through this, I discovered that there's a huge world of people who download and listen to just noise. If you go on YouTube, people use airline noise. Natural noise like rain is really popular, but some people just want to listen to some pink noise or some white noise. They use it to sleep. Here's some office noise, some pink noise. Water, beautiful. This is everything that says it's a spaceship noise is basically brown noise, really deep. A lot of people use this to concentrate. And it's a really interesting world that I discovered of people who use noise, because noise is almost always defined as an unwanted sound. So, there's people who obsess over just fan noise and they can't fall asleep unless they can hear a fan, and there's all of these fan noises available. There's even a sort of a specs race going on in the fan noise world where people are, no, we've got 64, no, we've got 128 simultaneous fans. So I thought that was all funny and interesting. Meanwhile, some friends and I, in January, took a visit to a slightly radioactive local attraction in the region of Oregon where I live. This is the Hanford nuclear facility where the American nuclear industry learned how to do interesting types of fission, purification of plutonium, etc., pretty much by trial and error, which means it's now a kind of a giant radioactive toxic waste dump. But there's areas that you can go to that are somewhat safe, but we wanted to be really sure we were safe, so we brought some dosimeters with us and some Geiger counters, and I got really interested in the sound of Geiger counters. I started thinking about how I'd been listening to them all my life, and they sort of most people who don't traipse into a radioactive area, which is wise, really that's their whole understanding of like the physical nature of radiation is hearing a Geiger counter. And I'd been wanting to do something, play around a little bit in Faust, and I thought, oh, well, a Geiger counter would be really easy. The other thing was that I was in the middle of a recording project. I'd given myself January to finish a set of home recordings that I'd been working on for a year in the studio that I have, which is just a truck in my backyard in Oregon where it rains all winter. So I was spending a lot of time alone, really sequestered in sound, ignoring every other important thing in my life, and putting my primary focus on recording and finishing, this music, these songs. But I'm kind of a procrastinator, and like a lot of people, I think when you know that your primary responsibility and your number one priority is to do this thing, suddenly your number two priority gets really interesting. And my number two priority was to just like learn Faust more. So I thought, well, I'll do a little bit of Faust on the side on Sundays, and I won't let it derail me. So I'm going to turn this off right now and show you another one I think is set up here to get a little Geiger counter sound. So I had a concept that was pretty simple. I knew that there was a sparse noise generator in noises.lib that basically sounded already mostly like a Geiger counter. I knew that Geiger counters tended to want to, if you will, expand the sound of every particle to an equal level. And so I came up with an algorithm that basically would, raise your +1 to -1 noise value by an exponent. Because it's exponentation, you had to first take the absolute value, then do the exponentation, then put the original sign back on, but it's pretty simple. So with that, I could use create a sort of a crunchiness component that allows me to go between like a lot of variation in amplitude to something that's pretty, it's always going to be a plus or a -1. And then I thought, well, it's going to need a little bit more character, and I'd listened to a lot of Geiger counters at that point, and they're all different from each other. So I thought, well, just get some filter out of the filters library, or actually, I picked the most boutique filter in Faust. It's the virtual model of the Moog ladder filter. That's really great sounding and has a lot of interesting qualities. So basically, I started out with a simple program that was just this. This was adjusting the sort of frequency of noise events to sparse noise. This was sort of compressing it. And then over here, I had, a frequency and a Q setting. And I thought, okay, I've got a Geiger counter, and I played with it a little bit. But then I just started playing around with my sliders some. And I started to hear all sorts of other interesting permutations of the same information. And keep in mind that I was in the middle of the rain in a metal box while I was playing with this, and I had constant rainfall outside. And it started to sound a great deal like rain on the roof to me. And I thought that was really interesting. And then, I also learned that you can get a bunch of other interesting sort of tones out of these filters. I just sort of got crazy playing with it. So from there, let's see, what did I do? I have a list of the things I did. It was like 3 sliders and maybe a button, and now it's this very large layout. I don't know that I've seen the Faust user interface language used in a more complicated app than this. It's a lot of knobs. So from there, I went on a sort of expedition that really, okay, let's listen to a lot of rain. I wandered around in the rain a lot. I listened to rain in different buildings, and I got a lot of rain recordings from YouTube. And I came to the conclusion that rain doesn't actually sound like any particular thing. I found some physical models for concepts of how a raindrop should sound. But really, rain is kind of like a drumstick. It's always striking some solid or semi-solid object and resonating that. And the sound of rain is the sound of objects around you. If you wanted to really do a beautiful 3D simulation of rain, you'd have to start with some sort of physical model of a world that the rain is falling on. the philosopher John Hull, an Englishman who went blind in his life, wrote some really beautiful things about the experience of rain and how it seemed to him to give his vision back. Because when it was raining, he could suddenly perceive near and far, all around him, the surfaces and the movements of the world. So I wasn't about to try anything that complicated, but I thought, well, what can we do to get a wider palette of possible rain sounds? One of the first things I did was I came up with a brown noise source to feed into this, just to get a little bit more low frequencies to play with, since I was using a low pass filter. Another thing I got to do was play around with the width, and that's sort of like normal sparse noise algorithm gives you a single sample of non-zero noise, kind of randomly selected, surrounded by silence. I came up with a sort of a more elaborate, broken apart version, where I was able to sort of trigger a gate and keep it open for a number of samples, which I could adjust here, and that would give a little bit of a, let's see if I can hear it better here, a little bit of a crunchier impact, which has a nice sort of like water falling in a puddle kind of tone to it. To me, kind of there. I don't know. By the way, I don't know how loud I should have this up. I don't want to hurt anybody's ears. It seems a little quiet to me, but it's because the speakers are pointing at you guys. Another thing that you find is that there's a little bit of variation between raindrops all the time. And so I came up with this system of flutter where I would just change a bunch of random values at the moment before a sound happened so that you could feed a little bit of variation. Let's see if you can hear it really well in here. Feed a little bit of variation into the tones that we're getting. Let's see. Trying to come up with some better illustration of that. So the flutter algorithms took a long time to get right. When you get into this thing where you've got a parameter and then you're trying to fluctuate it by another parameter, you get deep into a bunch of stuff that Ioannis Xenakis wrote about a long time ago. He wrote a bunch of algorithms without any actual programming language, just by kind of describing what a cellist would do in a situation like this. But he had a lot of good approaches. So Flutter got really interesting, and I decided to sort of put it on everything, and it became like a major source of like short-term fluctuation in the system. I also added a couple overtones here, and these are just basically we're splitting the signal between this fundamental Moog VCF filter and two other Moog VCF filters that are synchronized by an interval that you can define here, and then you can bring one or the other up. And this is useful when you've got a low fundamental. You can add a harmonic to it, and a lot of raindrop strikes sound basically like a thud, and then some number of harmonics kind of ringing higher up. So I was able to get at a lot of different specific raindrop noises that I was looking for with this system. Obviously, you could feed these sorts of noise impulses into a lot of different tone generators, but this seemed a pretty flexible layout to me. The last thing I got involved in, two things. One was that at some point I sprung a leak in the roof of my van, and rather than patch it, I got kind of obsessed with listening to it for a while. And I realized that, whereas rain falls really regularly, drips fall really, really regularly. And so I sort of figured out, well, what does it sound like if I'm just giving it a really constant, regular rhythm? And it's a little bit too mechanical, so I looked for a way that I could back that off, and basically my sparse noise algorithm in here takes an argument called the coefficient of periodicity, and I'm looking for like a fewer syllables word for that. But basically you can go from a really random distribution to one that's really organized based on the fundamental frequency. And if you back it off just a little bit, it's kind of a nice raindrop sound. Or it's about, if you take it down really slow, it's about how well I play the drums. Sometimes I play about this well. Techno is always this well. But it's interesting to play around with that, and I feel like you get a really nice effect when you're backed off just slightly from truly regular. The last thing I did after listening to this stuff a lot was realize that I could create some kind of interesting soundscapes I would put on in the background, but they'd sort of get a little bit dull. And the last thing that was missing from a model of weather was some really long period, slow variations, such as come with gust of winds and whatnot. So I came up with another source of fluctuation called drift. And this is just a very, very slow changing wave. Every now and then it changes to a new value, and there's like a slowing function so that it moves kind of slowly. And with that, you can kind of have a weather effect where the wind comes in. This is what we were listening to when we came in initially. And it's pretty nice for wind. It's pretty nice for rain. I have a better demonstration of it over here. I won't even get into the tuned stuff, but it's nice that you automatically get MIDI control on these, because it means that you can also do some interesting things, or you could before this presentation started. You can do some interesting tuned things. If you put the Q of the filter up high enough that it really tunes the noise, you can get some real noticeable notes. And so you can create kind of noise fields that are tuned. There's a few other features of it. It's online and available for you guys to look at. I'm kind of out of time talking about it. It's continuing to evolve, and I'm adding things to it. It's been really fun to play with. I encourage any of you to take it. It'll run in the online compiler or the online editor. It runs in Faust Live. I'd like to eventually break it down into something more parameterized that could maybe be used as a library. That's Weather Organ, simple as that. Questions?
Okay. So do we have questions? I have one. How many different sound generators do you need to use for, decorrelated?
All right. Well, it's interesting. You need, first of all, you need a random. Let's see. I get the question. I'm just seizing up. The sparse noise generator obviously needs to roll some dice to figure out when it's going to produce a sample. Then what it's a sample of is also a source of noise, although you can also use line in instead. So that's two. Then all of these flutter variables, each one wants to go to a different decorrelated new value every time the sort of flutter moment happens, which is like one sample before a noise event. And therefore, every time I add a flutter knob to something, you need another decorrelated noise source for that. Then the drift wave itself, which is shared between all of them, but it also needs a decorrelated noise source. And I'm sort of fudging the difference between audible noise and just random numbers for randomizing things, but most of that is random numbers. I eventually, just wrote some wrappers around multi-noise so that I could just pick a noise by an index and set like a master number of them that I would need in the whole document. And it's interesting because, every time I add one, it's not huge, but a measurable increase in computational needs, because you've got to run that out, that particular hunk of math once per sample per noise source. I don't think I've hit any sort of computational limit of this laptop, but I frequently am working with smaller embedded devices, And so I'm always kind of looking at just how fast I can get an algorithm to go before I try and cram it in there.
And any other question? Okay, I have another one. Are you developer? What was your programming background before starting using Faust?
I've been a software developer most of my life.
Okay.
You know, in JavaScript and C and C++, in Perl even, and PHP, unfortunately. And a lot of toy languages. I've done a lot of Arduino processing, C++ and C there. Faust is my first real exposure to a functional language. I started looking at some functional languages that seemed strange. I feel like the use case for a functional language to do signal processing is a real perfect marriage. I love how particularly well suited Faust is to the particular problem of transforming or creating waves. So it's been super head expanding. There's a lot. It's not like any other language that I had deep experience with. I don't know if other people have had the experience of coming to Faust directly from object-oriented or procedural or functional languages and needing to really understand, you know, once you take away the syntactic sugar, how different the model is. It was hard for me at first and annoying at first, but now I really love it, and I really think that Faust has altered the way in which I think about software for the better.